Welcome everyone to Golang Prague Meetup. It's number 5. It's our first virtual meetup, and some details about it I will give word to Vladislav.
Okay, thank you, Ladja, for the introduction. Hello, everyone. Let me again welcome you to this Prague Golang meetup. This is like our first virtual version. As you can see, there are still some technical issues. We're working on that. Sorry for that. But before we start, I would like to say that I'm really grateful that we have this opportunity to make this virtually, because it gives us possibility to connect with more people all around the world and to bring more diversity to our meetup. We are planning to do these meetups now more regularly. I say 2 or 3 months. So feel free to join in and feel free to say some topics that you would like to hear. But before we would actually start, I would like to talk a bit about the slide that I hope you see here. And that's just the description of all the platforms where you can find us. And of course, you know about meetups.com because you found us there as Prague Golang Meetup. But what's worth mentioning is that we are now a part of GDN, Golang Developer Network, which is a network that connects all the meetups all around the world that have something in common with Go. So have a look at that. There are some very interesting meetups there, so I recommend checking that. For another platforms where you can find us, we are on Gopher Slack. There is a channel Prague Meetup, so feel free to join us. Feel free to ping us any ideas that you have, any topic that you might have. We are still looking for speakers, so this is the great place for you to join us. Another place that we have, or another channel that we have, is Twitter. You can find us as Go Meetup Prague, and we will be sending messages out on Twitter about upcoming meetups, about meetups that were in the past, of course, links to the recordings and other things. So we would be glad if you followed us, of course. If you like more traditional way, then we have an email address. You can see it here on the screen. It will be shared on the other channels as well. And we have newly a YouTube channel. It has quite an ugly address, so we did this bit.ly here. And if you subscribe to us, if we get to 100 subscribers, we can get a nicer address. So that's a motivation for us, and we will be recording all the meetups and putting them onto this address or onto this channel. So you can go back anytime you want and have a look again, or you can share it with others, of course. If these channels are not great for you, you can, of course, connect with us directly, either with Vladislav or with me on any channels that you find, LinkedIn, Twitter, whatever works for you. And now I would like to introduce our speaker. We have actually a very good speaker for our first virtual meetup. Welcome, Bill Kennedy. Bill Kennedy is one of the most influential people in the Go community. And he's working in Go since 2013, and he has already trained like more than 10,000 engineers from all around the world. And I've actually been to 2 of his trainings, and they are really awesome. I recommend those. Besides that, he wrote a book, Go in Action. He's the main contributor of the Arden Labs blog. He has a podcast, Arden Labs podcast, and as I've already mentioned, Go Developer Network, he's managing it. So a lot of things going on. As for Bill, he's a very interesting, very important person for a Golang community. So welcome, Bill, and the floor is yours. Actually, one more thing before the floor is yours. If anyone has any questions to Bill or to us, please write them to chat. We have here this QA session. We decided that it would be easier just to use the chat. So if you have any questions, just ping to the chat. Bill will pick them up, or we will pick them up, and we'll try to answer all of those.
All right. I'm tired just hearing everything you just said. What's going on here? That's okay. We're going to have some fun over the next hour. We're going to have a much more practical, let me be able to share my screen, Vlad. I think you're going to have to get out of that. We're going to have a much more practical conversation about modules and really kind of talk about 2 things, how you get started with them in a project and some workflow. And then the things you should be thinking about for your project or your team in terms of how you want to set some of this up. The default configuration works great, but there's some privacy and potential maybe durability issues that you may not be aware of, and something you want to go back and talk to your team about. So we're going to go ahead and let me share. Let's see what screen comes up. Perfect. That's not necessarily a bad screen. I use Lucidchart for my whiteboard. So at some point we'll do some whiteboarding and we'll get that set up. Let me do two more things here. I want to hide the video channel because I don't need that. And the other thing I want to do is make sure I can see the chat. Now, I don't know if the chat, Vlad, do you see the chat window when I have it up here? I don't know if Zoom shows it or not, but all right. I'm going to assume that maybe you can or can't see the chat window, but I'm going to leave that up. So if you're asking questions, perfect. So if you're asking questions, I can see it, and I'll let you know I see the question, and then we'll get to it. Okay. So modules is pretty much now kind of the default way that we're going to be managing dependencies. And there's some settings here, and there's some workflow. And the beautiful thing is that the Go Please service now that's used for editor integrations has gotten very, very stable and very, very good. So we're going to see kind of all of that working in action. And then I want to kind of lay out a little bit of some of the workflows, high level semantics, right? Workflows that are happening. So you can kind of visualize what's happening when we run some of these Go commands. All right. So a couple of things here before we get started, because what I want to do is be able to write some code with you and go through that. Let's just create a talk folder. If the font's not large enough, let me know as well. All right, a couple of things. And you do not have to do what I'm about to do in your environment, but I want to do it here just so we can start really clean here. There's a couple of caches that Go has. There's a build cache, which is right now located there. I'm not really worried about that cache. That cache is to help speed up builds for packages that really haven't changed. This is kind of old school stuff too. It's moved into this location. It used to be under your Go path under PKG. And what happened is that PKG folder has now become the module cache. And you can see there's an environmental variable for that as well. And what I want to do is clean this module cache up. I want to start with a machine that is completely clean. So let's do the following here. I'm just going to split my window just so we can work from here for a second. Oops, that's not how that's going to work, is it? Let's move into the PKG folder. Now, I do still kind of maintain a Go path here, but the default Go path would exist off the root of your user folder. And I want you to see here that there are two folders in here, one called mod, one called sumdb. We're going to go deeper into what these folders are, but this is our module cache. Any code that we're downloading to build against will go in there. Now, somebody just reminded me recently that there's a go clean command with a flag called mod cache. Somebody just reminded me of that. This is one way you can clean that module cache up. Again, this is not something that you need to feel that you need to do, but you can see how that removed the mod folder from that location. So that's kind of cool. All right. So I'm using that go clean command to do that cleanup, and we'll come back to this folder in a second. But I just wanted to kind of get a brand new machine completely clean here. Okay. So let's pretend right now that we're looking to build out some code or even starting brand new. And I've gone out and I've created a repo for this talk project that we're going to be working on. And we can just keep the project really simple right now, right? I could do is just kind of decide to have a main.go in here, and we can really just start to get going. But before I open up any sort of editor, it's really going to be important that this project gets initialized to work with modules right from the very beginning. This is going to put the Go tooling in that module mode. It's going to put your editors in that module mode. And it's really now kind of the default way that we want to manage these third-party dependencies that we're going to be working with. We're going to talk, yeah, that's not for here right now. let's initialize this project, all right, for modules. Now, Go gives you a command called Gomod Init to do that. And if I had properly cloned a project from GitHub to do this, that's all I would have had to write, and Go would have come up with a unique name. One of the important things here when we init a project is that we want to give each project or module a unique name, because it also acts as a namespace for accessing the internal software related to this project. And it's really why I prefer that we start with a repo, because the name of that repo, the full canonical URL to that repo, is a great convention we use for naming our modules. So I've got a module out there already in a repo called conf, github.com, ardenlab/conf. That's what we would call that. Now let's pretend that we did create inside of Arden Labs a repo called talk. If we did, and that was the canonical URL to get to that source code, then this is the name that I would want to give to that module. If it's just a hack project and you're just playing around, you could just give it kind of any name you want. But assuming that we did already decide that we're going to be saving this in some sort of repository, I prefer to use that name. Now, a couple of things have happened here. We now have, or really one thing has happened here. We've got a go.mod file in place. And with that in place, we can now basically bring up VS Code and kind of start exploring a little bit this project and modules. All right, let me make this a little bigger. Perfect. So we don't have a really clean, I just touched that, right? So we're just going to go in there, we'll add a main, and we'll just get some code up and going. Okay, so I'm going to go one, if this is not large enough for you, you let me know. Okay, let's take a look at our go.mod file for a second. There's a couple of things in here that are important. One is the module name. Again, this is going to act as a namespace to access code that is internal in this module, internal to this project that we're working in. If I started to create other packages in here, and packages internally had to import those internal packages, everything would start off in reference to this particular name. It's almost as if you've been in Go a while, kind of relates back to the fact that this is like your go path to that internal code. And then you see on line 3, a version number here. Now, there's a couple important things here about the version number. The version number is telling the tooling what is essentially the minimum version of Go that we need to build this code. And it also is an indication for the tooling to know what its default behavior should be. One of the nice things that the Go team has been doing, and this is really difficult work. I mean, just the amount of, it's really tedious to do these things, but the Go team has made sure that if the Go tooling related here to modules sees a version in there, it behaves as if that's the version of Go that's running, and it behaves around those defaults. This is critically important because if it didn't, your build scripts and other things could break as you upgraded Go on your machine. So this version also plays a role in making sure that the Go tooling knows what level of backwards compatibility it needs to meet with defaults and things related to module tooling. And also eventually, maybe about 4 years from now, we'll end up with a Go 2.0, a major 2 change. And then this version is also going to be important to be able to tell the build system, you know, which version of the compiler, maybe we need a major 1 or a major 2. We're far away from that, but it does give us some setup. Now, the rest of this files, as we're going to see, is going to be there to kind of list the direct dependencies, for the most part, the direct dependencies that this particular repo, this project, this code base is working with. It's never going to be a complete list of the modules you're using. Since every module will have its own go.mod file, the Go tooling could go and kind of look at every Go mod file related and then build those lists. There's a special Go list command for those types of things. But we needed this in place to begin. Okay, so we've got this module file now. Now the fun part begins. Let's say we wanted to use some third-party package out there. We're going to want to reinvent the wheel. And for this talk, I'm going to use the conf package that I have here in Arden Labs. This is a package that I use in just about every project related to configuration. And again, it's going to be treated almost as a third-party package. And so if I want to start using this API, I'm going to have to reference this module, and then I'm going to have to download this code. I'm going to have to start using it. And there's a nice kind of workflow that we can work through to do that. So normally when I see a package that I want to work with pretty quickly, inside the import path, I would copy that URL that is to that canonical repo, and I would put it right in here. Now, the problem at this point is if I hit save, it goes away because we're not using it. And maybe I'm not 100% familiar or comfortable with the API yet. So a lot of times what I might do is pretend that I know about some API call like .new, right? Which really doesn't exist. But it is enough to give me two things. It's enough to make sure the tooling doesn't get rid of that import. And it really isn't a syntax problem either. So if I want IntelliSense to be working, if I want these things working in the editor, well then the problem here is I need this code to come in to my machine, and GoPlease needs access to this code as well. Since GoPlease is running in the background and feeding all this information to the editor, it needs this code as much as we do. But just this little setup that I've provided here, putting an import to the canonical URL. Again, this is really also why we want the name of our modules to match those URLs. That way, this name coincides with where that code is out there on the internet. But how do we get the editor? How do we get GoPlease to start being responsive with IntelliSense in getting rid of these messages? All right. The way I do it is once I kind of just set this up, I put the import in conf.new, whatever the package is. I'll come back to the command line here and I'll run the command gomod tidy. And what gomod tidy is going to do is go out of, and this is part of the workflow that I want to share with you, because understanding what gomod tidy does at a semantic level really kind of brings home some of the things you need to consider when it relates to leveraging modules in your projects. So let me just do this for a second. Let me just do a gomod tidy. And you can see a couple things just happen there. Gomod tidy somehow found version 136 of this package that I wanted to use directly. It found the source code for it. And then it found the source code for another package called GoCompare for some reason, right? Now let's take a look at a couple of things before we kind of diagram out everything that just happened when I ran gomod tidy. If I come back to our module cache, you'll see that the mod folder is back. And if we were to kind of walk in there, you'd see GitHub. You'll also see Arden Labs, and you'll see conf at that version. And there's the source code. And the Go build tool now is going to leverage this source code exactly here on disk in the module cache when we're going to be using version 136 of this code, which we're going to be doing. So gomod tidy somehow made that happen. Also, gomod tidy, if we come back to the project, added the Arden Labs conf to the Go module file as a required dependency for that particular version it found. And it also went ahead and added a new go.sum file to the project. It listed two hashes for each package that we're working with here. A hash here for the entire code base for conf, and a hash here for the go.mod file. And again, for some reason, it brought in GoCompare as well. And now GoPlease can tell me that we have a problem with our syntax because this function does not exist. And our IntelliSense is now working. There is a function called parse. And if we were to fix this code and do a go build, now the compiler can leverage this code and then link to this source code here in the cache to give us a complete binary. Lots of things going on here. And I really kind of want to walk through some of the big workflow points so we can get into the conversations around privacy and durability. So let's kind of start here. What's going on here? What was the workflow that Gomod Tidy did to even find any of this code? Okay. So let's go to our whiteboard for a second and kind of start to draw out some things that are going to be interesting. So here's our app, right? This is me, right? This is me right now on at my desk. This is my desktop. And we ran that Gomod Tidy command. And what happened then? Well, by default, what Gomod Tidy is going to do is look for all of that source code that it needs based on those imports and those canonical URLs. It's going to go and reach out to a service that's running up in Google Cloud. The service has kind of two names. Sometimes it's referred to as the module mirror. Sometimes it's referred to as the proxy server. And both names are fine. By default, this is where the tooling is going to go. Now, the following exchange of information kind of happened when I ran Gomod Tidy. The first thing that Gomod Tidy did, and again, we're talking about the semantics, the behavior. I'm not going to get into the nitty-gritty details of things. What's more important is the flow. All right. So the first thing that happened here, and maybe we can put some larger text here so we can read it, right? Initially, the first thing that happened was Gomod Tidy asked for a list. Asked for a list of versions that the module mirror knew about for our module name that we listed in the import, github.com, rnlabs.com. So it asked basically for a list of, let's say, known versions, all right? And at that point, what happened was the module mirror must have returned back a list, right? Now, where does it get its list from? That's the interesting, right? So it returns back a list here, right? Well, let's look at a couple of things. Let's go to the repo for the conf package for a second. And let's take a look at the different tags that are there. Okay. So you can see all of these semantic versioning tags that I've applied to code changes throughout the time that this project existed. And at some point, some project requested access to conf or even asked for a specific version, which meant that when asking the module mirror had to go out to, let's say in our case, GitHub, and get that information. So at some point, the module mirror said, no problem, let me go to GitHub for some maybe specific version that's being requested, right? So maybe for a specific version that's being requested. And what the module mirror did is said, fine, we'll go to GitHub. And then what it does is it generates essentially a zip file with all of the code related at some version, all right? And the module mirror is going to store all of these zip files. We can call these our modules at a given version. And so when I ask for the list of known versions, at that point, the module mirror already has all of this stuff and can return that list fairly quickly. Now, what if I just published a new version of my comp and now somebody comes in and asks for the version list? The module mirror is not going to necessarily know about that version, not until that version is, say, directly requested. one of the things that I always do after I create a new version of code is I usually run a command. After I tag a new version, I usually run a command immediately called gomod download. This is how I do it. And I might go, okay, on labs and conf at some, whatever the new version. Let's say the next version I tag is 140. This is usually the very next command I run on the command line. Because what that will do is make a request to the module mirror for a version that I know it doesn't have in its list. But since I've given it a version number, it can go out to GitHub, look to see if that version exists. And if it does, it can then go ahead and create another zip file with that version in it. And now it's a known version. So one of the things you should be doing once you tag a version of modules that you're developing for others related to, sharing, is you want to kind of make sure that it gets into the module mirror on your terms sooner rather than later. And this command's kind of like a cool way to do it. Okay. So a bunch of versions came across the wire, right? In other words, all of these versions would have came back across the wire because this is, at some point, all of these versions I tried to download off the module mirror directly. And you can see here that the latest, greatest version that we have is 136, which to me then is no surprise that 136 shows up here. Since this is a direct dependency that we're asking for, the version selection algorithm, minimal version selection, if we have time, we'll talk more about that, went out and got us the latest, greatest version of conf. So at that point, if we go back to our diagram, the list came back, and based on the list, then Gomod Tidy turned around and said, okay, I don't know why that's happening. Fine, you win. I'm not going to argue with you. Gomod Tidy came around and said, all right, no problem. I want, based on the list you gave me, what I want then is version 136. And lo and behold, that's exactly what we got. We came in and it sent the zip file at v136. Beautiful, right? But what happened next after this zip file came in? Well, the following things now have to happen. The zip file has to be essentially uncompressed, right? So that had to get uncompressed, which we saw that it did, because when I came in here, you can see that this file and that information is there. So that became uncompressed. Then what happened next? Well, then what next happened is the go.mod file was touched with that new information, including, as we saw already, the fact that we're going to be using 136 of conf. That became a required dependency for this code base. But what happened next? What happens next is actually really interesting. The two hash codes are generated for the code that we just got down. There's a hash code that's generated for the entire code base and one generated for go.mod. And in that particular case, once those hash codes were generated, this information was added to go.sum. So we did the hash codes and then we added that to go.sum. Now, this is where things get also interesting. Anytime we're adding new modules to our module files, like we're adding that new hash codes to go.sum, there's another step that now takes place. There's another server out there in Google's cloud, and it's called the Checksum. I'll make this a little larger. It's called the Checksum Database. And that sits out there in Google Cloud as well. The Checksum Database is just that. It's a database of checksums that is populated thanks to the module mirror. So remember when we went out and we generated these zip files because maybe somebody asked for a specific version of code like I did with Gomod download. Well, the module mirror not only compressed all of that, but the module mirror at the time also generated the same hash codes and stored those hash codes inside the checksum DB, right? This is where it's going to store those hash codes that it's generating. Cool. Now, what's nice about this is the following. Because those hash codes are there, now the Go tooling can do something new. And it's only when we're adding something new to go.sum. What happens now is that the tooling hits the checksum database. And essentially, it's a good way to think about it, is it's looking for the hash codes, right? So it generated hash codes, and it basically wants to compare the hash codes that it generated with the hash codes that are and can be found in the checksum DB. We do this compare. Now, if the hash codes match, what do we know? We know the code that we just got is the exact same code that the module mirror got back in the day. If it doesn't match, then we have a problem because somehow somebody's made some code changes since the module mirror took that code after it was versioned. Now, you might be asking me at this point, Bill, how can this be different if the module mirror is the one who generated the hash code and the module mirror gave us that code? Well, really, that should never be different. But that's assuming that we're always using the default settings here, which is to use the module mirror. We could choose not to use the module mirror from Google at any time or any given developer or any different compute environment, right? I mean, this is my machine, but I could be doing this on a CI machine. My friends could be doing things differently. And so we can't assume that everything's going to the module mirror. Plus, maybe you don't want to use the module mirror from Google. Now, why wouldn't you want to use that? One, you may not be able to if you're dealing with source code that isn't sitting in public repositories that the module mirror can access. Another reason might be just because you really are not comfortable, for whatever reason, to be hitting these Google servers because though Google has a very strong privacy policy and they're not really collecting data, they are gaining access to the IP addresses, at least, that are accessing or requesting this code. Even though all that's purged every 30 days or so via the privacy policy, some people are they just don't even want Google knowing what's going on. And so what might happen for some applications, okay, is the following. We might decide to set the module tooling, and I'm going to show you how you can do that in a second. We might tell the module tooling, look, when I do a Gomod tidy, let's say, I don't want you to go to the module mirror. I want you to go, we'll call it direct. I want you to go direct. Now, if we're going to go direct to GitHub, we're going to walk through the same exact scenarios, right? What are the versions you have? And then, great, thank you. Okay, give me this version. But the download side of it is going to be a little bit slower, isn't it? Because in this case, we don't already have a zip file that's available. We've got to basically download all the individual files, right? It's going to be a little slower to do, and we could potentially go direct and do that. That's fair. This is where this is where the hash codes become really important, because at this point, maybe the project originally got the original code from the module mirror, in which case we wrote those codes to the sum. We even checked them and everything was great, right? Now we're going direct. This is another computer. It already knows about needing these versions. Maybe we're running a gomod download command, right? We're running a gomod download command in our CI. These files already exist. Nothing's changing here. We do a gomod download, but we're telling the Go tooling to go direct. And so now these individual files for each one of these modules for these versions start coming down and they get placed into our cache. But what happens now when that is, right? Well, one of the big differences now is since this is already added to the go.sum file, what we want to do is what? Well, once we download this, right, and we put it in the cache, the tooling again is going to generate the 2 hash codes. That's going to happen. We're going to generate the hash code. But this time, we're not going to go out to the checksum DB. What we'll do is we can compare it with what's in go.sum. Now, that's really important because if the new code we brought down that we just generated hash codes for doesn't compare with the hash codes in go.sum, we have a problem. And this could very well easily happen. Couldn't I do the following? Couldn't I go into my conf package, delete this tag, make a code change, commit and push that code, and re-tag this 136? I could. Now, anybody using the module mirror is going to be pretty much safe because the module mirror is going to reject that, right? It already has a v16. It's all there. But anybody going direct now who's pulling 136 would get the new code changes. And so it's so critically important that we have this go sum and that it's saved with the project, because anytime any one of these modules in any of these go mods files need to be downloaded because it doesn't exist in cache. If those downloads are happening directly, then those hashes have to be compared so you can sleep at night knowing that the code you just downloaded, say directly from GitHub, is the same code that we downloaded from the module mirror. It's really, really important. Now, you have another choice, actually. You may decide, I don't want to go to GitHub, it's too slow. But I don't want to go to Google either because I don't want Google knowing what I'm doing. So what's another option? Well, another option actually is to run a private module mirror or private proxy server. That's absolutely a valid thing to do. And you might want to do this as well because of packages that can't even be accessed on the public internet, which we haven't even talked about yet. But let's continue down this road here. Maybe what we decide to do is stand up one of these private module mirrors, which now means that when our app is going to be doing that download, right? Same kind of workflow here. Maybe we're doing that download. What the app can do is not go direct to, let's say, GitHub. It can come direct here. Oops, sorry. All right, you win. It can come direct here, but not even direct, right? It can essentially go to the private module mirror. Now, there's some real kind of advantages, I think, to this that could be interesting. One, the private module mirror now is probably on that local network, on a network, so we're not going to have to get individual files. It, once again, will go through this same sort of workflow, but we're doing it here. So when we do that, we can pull down zip files, which is much faster. Now, the module mirror, again, just like our other one, will have to go out to GitHub for those modules that it doesn't know about. And then in which case it can go and do all that good stuff. And you have it here locally. The other nice thing about your module mirror is that maybe you're running something like GitLab and you don't really have it exposed on the public internet. Maybe you have it only on our private network, which now means that if your app is asking for private modules, well, the private module mirror has access to it, and it can also generate modules at a certain version for even your private code. One of the things we don't want to do, right, is go to, let's say, the module mirror here, right? This would be a nightmare. Somebody went to the module mirror here looking for something in this GitLab, which is not there. What's going to happen if that's the case, right? Well, I mean, Google's not going to even be able to access that GitLab environment. And then one of the things you did is you said to Google, hey, Google, can you go fetch me my super secret package at version 2? And the module mirror has to come back and say, couldn't find it. Sorry, probably return a 404, in which case now your app is going direct. And it ends up working. And you have no idea. You keep going off to Google and asking them for things that they know that they just can't access. And you're kind of letting, at some level, Google know what's going on. So we don't want this scenario, right? Like that scenario is no good. That's not going to work. And so what are your options then if you don't want to use a private module mirror? I like the private module mirror because from a developer standpoint, we just come here. The module mirror can be configured to go to your private direct. It can even be configured to go to the proxy server if you choose to do that for your public, or it can go just direct to those canonical URLs and you keep everything nice and private here. The other option, again, is just to always go direct. And I'm going to show you how to set all of these things up. Now, let's get this set up. And then there's some other conversations here that I want to share with you so you can kind of see some of this. But the key here on the privacy side is going to be, do we care if Google, for at least those packages that are out there, those modules that are out there in the public internet, do we really care that we're leveraging their compute infrastructure to be able to download these things quickly? That is the default, and I'm okay with it. Like they're really not doing anything with the data. And you're getting all of the benefits of durability because those systems aren't going to go down. If you're using, again, the private kind of GitLab, you can still use module mirrors, and then I'll show you how to tell the tooling to go to GitLab directly if you want. When it comes to a private module mirror, you have really two choices. You have the Athens project, There it is, and they just updated a new release. I'm going to run this locally so you can see it. And then if you're already using JFrog, they have a product called Artifactory, and they have, as part of that solution, a module mirror as well. So you have these choices there. I kind of like the idea of having the private module mirror in the case that configuration at the developer side is cleaner. And then the harder configuration is done here. Okay, let's kind of explore all this already. Now, you already saw me hitting the public module mirror, but why was that the case? Let's go look at our Go environment for a second. In our Go environment, you're going to see this environmental variable called Go proxy. I want you to notice what the defaults look like. What the defaults say is, if you're going to go download anything, go to the proxy server first in Google. And if they return a 404 or a 401, then go directly to that canonical URL like GitHub and those sorts of things. That's kind of what we just saw happen. Now, let's do the following just so we can have some fun here. I'm going to go ahead and go back into this module cache here. And I'm going to do our go clean mod cache command again. And we got rid of it. And I'm going to do one other thing as well. I have a version of Athens already, an image of Athens already running that we can run in Docker. So if I run this command here, then what I'm going to be doing is now running a Athens local module mirror instead of going out to Google. I'm not done yet because we've got to make one change to this environment variable, right? I don't want to go here. I'm going to export this and tell it to just go to HTTP localhost 3000. Okay. So now I'm telling the Go tooling that the only place you're allowed to go to download things is my local Athens server, which now has to go do a bunch of things. So let's do the next thing as well, just so we can make this work. I'm going to remove the 2 Go files from my project. All right. I'm also going to close my VS Code window for now. Quit that. We're going to redo the Gomod Init, github.com/arnlabs/talk. There it is. And we already know that my main is assuming that we're going to be using that, right? So if I do a Gomod tidy now, we should see some logging showing up in the bottom frame. There it is. So now what you saw is that this is taking a little longer, and not because Athens is slow, but primarily because Athens now has to go directly initially to go get all this code, to compress it, to zip it up, to then be able to deliver it to us. Yeah, so enforcing configuration on the developer's machine is an interesting problem, which is really why I like sometimes having the module mirror there, because I think it's easier to maintain that stuff, right? But it is definitely a question that has to be talked about as a team. That's why I'm bringing these conversations up. How do we guarantee that every developer environment is set properly off the defaults if we're going to be doing this and if we're going to be doing that? But as you see here, we just hit the local module mirror to go and do that. All right, brilliant. Let's do this again, but I'm going to make a couple of changes again. I'm going to remove my module files again. I'm going to clean my module cache again. If I don't clean the module cache, the Go tooling has no need to do that. I wish I had a better answer for you, Vlad, but this to me is so like workflow dependent on the team, but this is why we're talking about it. So you raise this issue and we identify that solution. All right, I've moved the mod cache out again. I've gotten rid of the initialization. Let me go mod, let's do this again. I'm going to export Go proxy. And this time, all I'm going to say is we go direct. Okay. Now what I'm saying is I don't want to use any module mirrors for nothing. Go proxy, just go direct. Now, what does that mean? It means that I shouldn't see our Athens server being used again when I do a Gomod tidy call. We'd have to initialize it first, sorry. Let's initialize it. Now we can do a Gomod tidy. And we're not seeing any output again because we're going direct. All right, let's have a little bit more fun with this, right? Let me unset Go proxy for a second. And that should put us back in our default, which is right there, all right? And actually what I'm gonna do is change our Go proxy again to use our localhost 3000. There it is. I wanted to use, normally you would say comma direct in case that returned a 400 or a 404, which I'm not worried about right now, but, HTTP. And let's go back and say we're going to use Athens. And what I'm going to do as well is, stopped it. I'm going to start it again. Okay, you win. Docker run. All right, let's just start it again so it's completely clean again. And I want to share with you a couple of more environmental variables here that are important. The GoSumDB, if you notice, is not a fully qualified URL to get to the Checksum database. It assumes that if you're using a particular proxy server to get to the if you're using a particular proxy server, then it assumes that it can go there, or that, I say that same network location for GoSumDB, which then means that also that we can tell GoSumDB to go through, let's say Athens, or go through, but Athens really doesn't run a checksum database. The only checksum database that I know of in existence is Google's, which is interesting because what does this mean if you've decided you don't want to go to Google for the module mirror, then we pretty much assume that we don't want to go to the checksum database as well. So what does it mean for comparing the hash code? Essentially, if we turn off the checksum database, then what happens is the first time that the hash codes are added to go.sum, they're added, but they're not checked. And now that becomes your hash code of truth for any other kind of downloads that happen. Remember, you only go to the checksum DB the very first time you write those hash codes to go.sum. Once they're there, we don't check them again. So if you're not going to use the checksum DB, then this extra check is kind of just, you walk away from it. It's not being used. I never remember the flags for that, Vlad, and probably doing that is better. There's just too much going on in my head and I never remember that. So I just export them, but that's probably a better way to do it. To use the go env minus W, to be honest with you. Okay. Now let's say we wanted to go to the module mirror for everything but our GitLab. And I don't have a GitLab right now. But let's say we want to do that. Actually, in this case, I'm going to use the private module mirror so you can see it. But let's say we decided that we want to go through our module mirror except for github.com. For whatever crazy reason, we don't want to go through the module mirror for github.com. We want to go direct, which includes not just the module mirror here, but the checksum DB. Okay. There is an environment variable called goPrivate. Now, what goPrivate does is it sets these two environmental variables for you, go_no_proxy and go_no_sum. These take basically regular expressions that can be used to filter the requests that we're making. So if anything matches up against these variables, if it matches up against this variable, it essentially ignores goProxy and goes direct. If it matches up against this, it ignores GoSumDB and goes direct. All right. And normally, if you're setting this at the same time. So goPrivate is a convenience variable to make those two the same. So essentially, I could say this. What I'm saying now is, if you get any request for a module to github.com, we're going direct. Do not go through the module mirror. We look at the environmental variables again, you'll see they're both set now because I set goPrivate. If they have to be set differently, you'll do that individually. Now, what does that mean? Well, what do we know right now? We've got goProxy set to Athens. We saw that work, but I said anything that's github.com go direct, which now means that we're going to remove our go.mod. I'm going to do gomod, go clean mod cache, just so we can see it all work. Let's init again. Now, if I do a gomod tidy, we see no output. Everything's being downloaded directly again, and that stuff is being respected. And so you can see here how the use of goPrivate told to go tooling, at least for anything github.com, you're not going here or you're not going here, you're going to go direct for these particular things. What's nice about Athens is these same types of privacy, like I can say the goPrivacy stuff is built into the module mirror at Athens. And that's why I said sometimes it's nice to have it all configured there, where all we have to do on our dev machines is essentially just change Go proxy, like I did, to point to, let's say, Athens. And then inside of Athens, we decide where you go for certain domains and certain types of code. And we make sure it's all kind of locked in there. Really nice. So we can see that. And now that code will be there again, and we're able to build. Now, there's one more thing I want to share with you. We've got some basic knowledge now of what's happening. If we're going to the module mirror, or we're going to a private module mirror, we're going direct, we have to go ask, what are the known versions? We get back a list. We choose one based on the minimal version selection algorithms. In this case, it's a direct dependency, so we can get the latest, greatest. And then either we get an existing zip file already with hash codes at that version, or if we're going direct, we have to download all the source code. Once we download it, we uncompress it, we update our go.mod, we generate 2 hash codes. If those hash codes don't exist in go.sum, we can check the checksum DB if it's not turned off. If the hash codes already exist in go.sum, then we compare with what we have in go.sum. If they match, life is good. If none of those hash codes match, you know that some funny business is going on, and you won't have to build against that code because somehow it's changed from the last time some known entity downloaded it, just like me deleting a tag, changing it, putting back a tag. Now, there's one more quick thing I want to talk to you about. There's another command here that we can run called Gomod vendor. And it's something that I really kind of push developers to do when it's reasonable and practical to own all of the source code for your project. I think you should run Gomod vendor, save that source code in your project and save it to your repo. There's many, many advantages, I believe, in doing this. Now, when I say reasonable, practical, what I'm kind of saying is that we're not talking about like 80% of your code base probably being vendored, right? When I think about Kubernetes and Docker projects, I don't think I would use the vendor command for those projects because the dependencies are pretty extensive. But most projects, at least that I work on, it's not that extensive. And so it's nice to manage and maintain your own code. Now, what are some of the advantages of vendoring and owning the source code? Well, the first thing is that the module mirror here, the public one, what if I decided one day that I don't want anybody using conf anymore, and I remove the repo, and then I send a request to Google, and I tell Google, get rid of this. Now, what happens when they have to comply, and you go to download this, and the module mirror doesn't have it? You're done. You can't build anymore. You just can't build. And I never want to be in that situation. So by maintaining my own vendor folder with that code, if that developer decided that nobody's using this anymore, well, I still have a copy of it. I don't have to go scrambling to look in somebody's mod cache to see if we can find it. It's already part of the project. Now, eventually I have to respect that developer and I'll have to remove this, but I can do it in a reasonable time frame that hasn't broke my build process. Now, you might think, well, you know what? A private module mirror like Athens gives you the same kind of vendoring. And in a sense, I don't think it's a bad thing to think about. Bill, I don't have to vendor in the project because my module mirror has it. And if that developer removes anything off of GitHub, well, guess what? I have it here and I still have the same amount of time. That's true as long as you're really confident that that module mirror and its disk space will never crash and burn, then that's fair. But if you want the highest level of durability, you want the highest level of reproducibility, having the code in the project is the best way to do it. There's also some advantages here. If you want to debug through this code, it's really hard to do that from the module cache. Right here inside the project, I can see it. I can put print statements in here. I can play with it and hack with it. Sometimes if it's my own projects, I'll make the code changes under vendor first, make sure they all work, and then I can apply them back to the other project. So you have the ability to also debug this source code right here inside the project. I'm not a fan of debuggers, but if you are using a debugger, you can debug through here really cleanly. And the last thing, especially for my friends in Europe, I've heard stories of people being in the office late for a train, doing a git pull to bring down the project. Then they run out of the office, they get on the train, the internet is spotty, and suddenly they go to do a go build and they can't download the code they need because the network is just too weak, or they went underground. And now they can't build the project even though they did a git clone because they need a network to download all the new dependencies. So one of the other nice things here about keeping a vendor folder is if you did that, if you had done that git clone or git pull, you wouldn't have needed a network. You would have had everything here as well. And so I just think there's just these huge advantages to the vendoring here. And I'm always going to recommend it until it's not reasonable to do so. Okay. But again, you could, if you can really make sure that it's a reliable environment that isn't going to crash and there's backups, you could potentially do it there. But then you have the same networking issue when you get on the train. I just think there's just too many advantages there for that. Okay, it is 2:10 at this point. So we don't really have time to get into kind of minimal version selection conversations here. So I'm not going to try to do that and rush through something, but I do hope and I do think that this at least gives you a decent understanding of those initial workflows, the things you need to be thinking about in terms of privacy, the things you need to be thinking about in terms of durability, with managing, potentially vendoring that code, the things that you have to think about, like what was asked, well, how do we make sure our development environments are all set properly for these environmental variables? Yeah, these are things that you're going to want to make sure are set, and those settings may only work for one project versus another. So maybe you have to source things for a project, maybe you have to do, but they're conversations that you want to have. And that's really the point of this talk, to just give you the understanding of some conversations that maybe you're not having that you should. So that's what we got today.
Thank you very much, Bill, for this awesome talk and for accepting our invitation. And thank you everyone for attending this. I'm just going to share my screen for a few seconds again so that you can again see what are the channels where you can find us, and especially the YouTube channel where you can find the recording from today's session. Of course, we will be trying in the next sessions another formats and other platforms, so bear with us, and I hope to see you the next time. Thank you very much for attending.